will be x and y. Let's say z equals x plus y. Then we will return our value z. So I'm not going to print z directly right now. Let's subtract x and y. Subtract z equals x minus y. Return z. Multiply x times y. Then divide. X divided by y, return z. Let's invoke our add function, pass in two numbers, 1 and 2. Then I'm going to print the result. After adding these two numbers together, the result is 3. What about subtract? Subtract 1 and 2. The result is -1. Multiply. The result is 2. Then divide. 1 divided by 2 is 0.5. After we resolve this function, a value is returned. Just imagine that after we finish this function becomes whatever is returned, 3. This function becomes -1. This function becomes 2. This function becomes 0.5. Let's write something a little more complex. We will create a function to create a full name. Create name. We'll need two parameters for a first name and a last name. I'll name these first and last. What do we want to do within this function? Let's capitalize the user's first name. First equals first dot capitalize method. Then do the same thing with the last name. Last equals last dot capitalize. Then I'm going to return the user's first name plus their last name. Then I'll add a space in between their first and last name. This is also valid. Outside of the function, let's create a full name variable, then invoke the create name function. So this function is going to capitalize the first and last name for us. I'll type in my first name, all lowercase, same thing with my last name. Then let's print our full name. And here's my full name variable. We sent our function some arguments, we have some parameters set up, we took those values, made them uppercase, then concatenated these strings together, then returned them as a single string. Let's try this with a different name. SpongeBob SquarePants. SpongeBob now has a full name. The first and last names are now capitalized. Using the return statement, you can return some data back to the place in which you call a function. Well, everybody, that's a function. It's a section of reusable code. To call a function, you type the function's name, add a set of parentheses. You can send a function some data, which are known as arguments, but you'll need a matching set of parameters. You also do have the option of returning some data back to the place in which you invoke a function. We'll be using functions a lot in the future, but we will get more practice with them. And those are functions in Python. Hey everybody, today I'm going to explain default arguments. Default arguments are a default value for certain parameters. The default is used when that argument is omitted when you invoke a function. In the last topic, we discussed positional arguments. Today we will be examining default arguments. Then in future topics, we'll examine keyword and arbitrary arguments. Let's begin. Let's define a function to calculate net price. There will be three parameters: an original list price, a discount, if there is one, and sales tax. We will return a net price, and here's the formula. List price times 1 minus our discount percentage times 1 plus our sales tax. Maybe I'm buying a PlayStation 5 for $500. I will pass in $500 for the list price. Well, I can't actually execute this function without also passing in an argument for discount and tax. Perhaps the discount is 0 and the sales tax is 5%, 0.05. Well, this would work, and I should probably put this within a print statement so you can see it. There we are. My total is $525. The list price of $500, no discount, and 5% sales tax. Now suppose that maybe 90% of the time when we're executing this function, most of the time discount is 0, and our sales tax is almost always the same. What we could do to make this function a little more flexible is to set these two parameters to have a default value. In place of sending in 3 arguments, we can pass in 1, then set our discount and our tax to have a default value. So I will set discount to be 0 and tax to be 0.05, meaning 5%. So this function would work. Our total is $525, and that's assuming that our discount is 0 and our tax is 5%. The nice thing about using default arguments is that, let's say that somebody has a discount. Well, this function would also accept up to 2 additional arguments. So let's print our net price, 500, and our customer has a coupon for 10% off. I'll add a second argument of 0.1. If we're passing in an argument for our discount, we'll use whatever is passed in rather than the default. Our total now is $472.50. Or maybe this time, they are not paying sales tax. I will set the sales tax to be 0. Now the customer's total is $450. So that's kind of the nice thing about default arguments. It makes your functions more flexible, and it can reduce the number of arguments, especially if the arguments that you're passing in tend to be consistent. Most of the time people don't have a discount, and almost everybody is paying 5% sales tax. Why pass in arguments if we don't have to? Let's cover an exercise. We'll create a count up timer. We will import the time module. We will define this function, define count. There will be 2 arguments, start and end. For x in range start, comma, end. Within the range function, the second argument is exclusive, so I'm going to add 1 to the end of our time. Then I will print x. To make this thread that's running the program sleep, you can access the time module's sleep method, pass in 1 for 1 second. Then outside of the for loop, let's print the word done. To invoke this function, I need to pass in 2 arguments, a start time and an end time. I'll set the start time to be 0, the end time to be 10 seconds. So we start at 0, then we will increment by 1 every second. I'll speed up the video, I think you get the idea, but we'll stop at 10. Let's assume that most of the time a user would like to begin at 0. Well, we don't necessarily need to pass that in as an argument. Let's set our start parameter to have a default value of 0. We only need to pass in 1 argument, but we do have a problem. Non-default arguments should follow default arguments. So if you use any default arguments, you'll want to be sure that they're after any positional arguments. So let's reverse these. And that should work. So now when I run this program, it's assuming we'd like to start at 0, but we'll need to pass in an ending amount of seconds. When do we want to stop? That works the same. But now we do have the option of starting at a different number. This time, let's end at 30, but we will begin at 15. We're beginning at 15, then we will count to 30. I'll speed up the video. There we are. All right, everybody. So in conclusion, default arguments, they are default values for certain parameters. The default value is used when an argument is omitted. They can make your functions more flexible and reduce the number of arguments you have to pass in, especially if those arguments are consistent most of the time. So those are default arguments, and in the next topic, we will discuss keyword arguments. And well, yeah, those are default arguments in Python. Hey friends, it's me again. Today I'm going to explain keyword arguments. A keyword argument is an argument preceded by an identifier. It has a few benefits. It helps with readability, and the order of the arguments doesn't matter if they're keywords. Keyword arguments are one of 4 basic styles of arguments. We discussed positional, default, then next we'll discuss arbitrary. But today we'll be focusing on keyword. Suppose I have a function to display a message, like a greeting. I will name this function the hello function. We will need a greeting, a title, Mr., Mrs., Dr., a first name, then a last name. All I'm going to do within this function is print an f string. I will print my greeting, the user's title, first name, last name. Then to invoke the hello function, I will need to pass in 4 arguments: a greeting, a title, a first name, and a last name. So for my greeting, let's say hello. The title will be Mr. The first name will be SpongeBob. Last name, SquarePants. So you know, this does work. We're currently using positional arguments. The position of these arguments does matter. So what if I were to switch these around? We have hello SpongeBob SquarePants followed by Mr. Hello SpongeBob SquarePants, Mr. An optional feature when sending arguments to a function is that we could turn these into keyword arguments. Prefix any arguments with the name of the parameter, followed by equals. Title equals Mr. First equals SpongeBob. Last equals SquarePants. Then with these keyword arguments, the order really doesn't matter. Maybe we move the first name to the end. And this still would print out as the same thing. We have title, first name, last name. If you're mixing and matching positional arguments and keyword arguments, you want to be sure that the positional arguments are first. So if I was to move the string, our greeting, to the end, well, this technically wouldn't work. We have a syntax error. Positional arguments follow keyword arguments. So make sure any positional arguments are first before using any keyword arguments. 2 helpful benefits of using keyword arguments is that it helps with readability, and the order of the arguments doesn't matter. We know what this argument is, as well as these 2. Title, last name, first name. Let's say we have a first name and a last name. John, James. These 2 names kind of sound like first names. Is our first name John, or is it James? We could use keyword arguments to clarify which is which. You thought John was the first name, but it's actually the last name. And the first name is James. Then our title is still the same. Hello, Mr. James John. Let's cover another example. I'm going to print the numbers 1 through 10 using a for loop. For x in range 1, 11 because the second argument is exclusive. Then I will print x. After each print statement, we print a new line. Do you remember in previous topics how we would follow our print statement with comma and then a new character, such as a space? Well, end is a keyword argument found within the built-in print statement. In place of ending each print statement with a new line, we are using this keyword argument of end and setting it to be a space. Another one is separate that's found within the print statement. Maybe we have some numbers. They're all separate strings. The numbers 1 through 5. I can use the separate keyword argument, then separate each of these strings with a given character or characters. I will separate each of these strings with a dash. A lot of built-in functions, such as the print function, they have some keyword arguments you can use. Let's go over an exercise now. We're going to create a function to generate a phone number, but we'll need to pass in a country code, area code, the first 3 digits, and the last 4 digits. Let's define this function as define get phone to get a phone number. We have a country code, area code, first meaning first few digits, then last meaning last few digits. We will return an F string. We will place our country code first, dash, then our area code, dash, the first few digits, dash, the last few digits. My phone number, phone num, equals, I will invoke the get phone number function we just created, but we'll need a country code, an area code, first few digits, then last few digits. And remember, the order doesn't necessarily matter. Usually I try and be consistent with the order of the parameters. Make up a phone number. I'm in the United States. My country code is 1. Area code 123. The next few digits will be 456. The last few will be 7890. Then let's print this phone number. Print phone num. And here's my phone number. Although you can change it up based on how you do phone numbers in your country. This is typically how you would see a phone number in the United States. Alright everybody, so those are keyword arguments. They are just arguments preceded by an identifier that matches the name of a function's parameters. It does help with readability, and the order of the arguments doesn't matter. When invoking a function, it could be helpful to identify some of these arguments. And well everybody, those are keyword arguments in Python. Hello friends, it's me again. Today I need to explain arbitrary arguments. Arbitrary meaning a varying amount of arguments. We don't know how many arguments the user is going to pass in when they invoke a function. To accept a varying amount of arguments, developers tend to use these parameters of args and kwargs. Args means arguments. Kwargs means keyword arguments. You would want to prefix each of these parameters with the unpacking operator, which is an asterisk. When you invoke a function that has args or kwargs as parameters, you will pack all of those arguments into a tuple if it's args, or a dictionary if the parameter is kwargs. Let's go over an example. I will create a function to add two numbers together. Define add function. There will be two parameters, a, comma, b. All I'm going to do is return a plus b. I will invoke this function, pass in two arguments because we have two parameters set up, 1, comma, 2. Then I'm going to print the result. Big surprise there, my function returned 3. Alright, well, what if I would like to pass in 3 parameters this time? Well, I can no longer use this function. The add function takes 2 positional arguments, but 3 were given. I could modify this function so that it could accept a varying amount of arguments, any amount. I'm going to replace the parameters with asterisk, then the word args, meaning arguments. So when we use the unpacking operator, what's going to happen now is that with the arguments that we pass into this function, we will pack them all into a tuple. And if you don't believe me, let's test it. I'm going to print the type of args. Then I'm going to remove this print statement for now. My parameter args is a tuple that I could work with. We can use the built-in methods of this tuple, or we could iterate over it. I'm going to iterate over this tuple. For every arg in args, for every argument in arguments, what we'll do is create a variable named total to keep track of the total. Total plus equals the current arg that we're iterating over. Then at the end, I will return the total. Let's print the result. Print, add these 3 numbers together. There we are. My total is 6. Then we can pass in any amount of arguments. 4 this time, maybe 5, or even 1. With my parameter args, you can change this name to something else, like nums, meaning numbers, for every num in nums. Total plus equals num. This would work too. The name of the parameter isn't as important as the unpacking operator. Just by typical naming conventions, people tend to stick with args, but the parameter name can vary. Let's try a different example. Let's create a function to display somebody's name. Display name. we will accept a varying amount of arguments. Use the unpacking operator, then follow the unpacking operator with the unique parameter name. For every arg in args, let's print each argument, then replace the ending character of my print statement with a space. Now, sometimes people can have a varying number of names in their full name. There can be a first name, middle name, last name, maiden name, a title, etc. So I'm going to pass in just a first name and a last name. SpongeBob SquarePants. If I need to add a middle name, I can do that. SpongeBob Harold SquarePants. Or a title, Dr. SpongeBob Harold SquarePants the third. Yeah, as I was saying, with the unpacking operator, followed by a unique parameter name, you can pack all of these arguments into a tuple, which you can use within this function. Now let's discuss kwargs. You use two unpacking operators. Then typically people follow this with the word kwargs, meaning keyword arguments. It allows you to pass multiple keyword arguments, which we discussed in the last topic. I think this would be great for an address. Define print address function. Use double asterisks. Then we can add a parameter name, but people usually stick with kwargs, meaning keyword arguments. Just as a placeholder, I'm going to type pass. Pass doesn't do anything. I want this program to be able to run. We'll get back to this function momentarily. I'm going to invoke this function, print address, then pass in multiple keyword arguments. With an address, you would typically have a street, a city, state. Depending on what country you live in, you may have more or less of these keyword arguments. I live in the United States. We have a state. Then a zip code. Okay, my street will be, I'm just making something up here, 123 Fake Street. City will be Detroit. State, Michigan. Zip code, 54321. Just to make this look better, I'm going to place each of these keyword arguments on a new line. For me, that's just more readable. But you do you. When I pass in these keyword arguments, we will pack them into a dictionary. Just to prove it, let's print the type of kwargs. Look at that. Class, dictionary. Within this function, you can treat kwargs as if it's a dictionary. There's a lot of built-in methods, or we could iterate over the keys, the values, or both. To iterate over the values, let's say for every value in our dictionary kwargs dot values method, print every value. Here's all the values. For the keys, let's change this for loop to be for every key in kwargs dot keys method, print every key. Here are the keys. For both, you could say for every key, comma value in kwargs.items method, print every key. Actually, let me turn this into an F string. Print every key, colon, value. The items method will return key value pairs. We can pass in a varying amount of keyword arguments. I'm going to add an apartment number. Apartment equals 100. Our keyword argument of apartment was packed into a dictionary along with all of these other keyword arguments. So that's kind of nice. We can pass in a varying amount of keyword arguments. Let's cover an exercise. We're going to use both args and kwargs together. We will print a shipping label. Define shipping label function. The parameters will be both args, comma, kwargs. Then just for now, I'm going to write pass, just so that this program will work for now. We'll fill in the shipping label function momentarily. When we invoke the shipping label function, we will first pass in any positional arguments, followed by keyword arguments, and it won't work the other way around. I'll prove that in a little bit. So let's say we have Dr. SpongeBob SquarePants the third. Then I'll add my keyword arguments. I'm going to put this on a new line. Street equals 123 Fake Street. Apartment equals 100. City equals Detroit. State equals Michigan. Zip equals 54321. When we invoke this function, we have a mix of arbitrary positional arguments and arbitrary keyword arguments. This shipping label function is designed to accept both. You do need args first, followed by quargs. This program will run, but if we have it the other way around, quargs followed by args, it's not going to function properly. You can see that we have a syntax error. With your parameters, make sure that your keyword arguments follow your positional arguments. Let's iterate over the positional arguments first. For every arg in args, let's print each arg. Then I will change the ending character of my print statement to be a space. Here's the name of the user who we're shipping something to with the shipping label function. I will print a new line. Then we will iterate over all the keyword arguments. For every value in my dictionary quargs.values method, I will print each value. Then I will change the ending character of my print statement to be a space. Alright, it's not looking too bad so far. If you were to remove some keyword arguments or some positional arguments, this should work still, which it does. I'm going to change the format of this address slightly. Let's add our street on one line, then the city, state, and zip code on the next line. Let's get rid of this for loop. To print the street, I'm going to print, use an f string, add a placeholder, quargs.get method. I'm going to get the street key. With this get method, you'll probably need to place them within single quotes, because if you use double quotes, Python gets confused as to where this f string ends. We will use single quotes. Let's test it. All right, we have a street. On the next line, we will print the city, state, and zip. Print f string placeholder quargs.get within single quotes the city. I'll add another placeholder. Quargs.get state. Then quargs.get zip. Let's see what we have. All right, not too bad. What if the user has an apartment keyword? Apartment equals number 100. Well, we should probably add that too. Within this top print statement, I will add another placeholder, invoke the get method of the dictionary. The key we're looking for is apartment. Dr. SpongeBob SquarePants, 123 Fake Street, apartment number 100, Detroit, Michigan, 54321. What if our print statement is set up to display a street and an apartment, but the user doesn't have an apartment? This would display none, and we don't want that. I'm thinking what we'll do is we'll place this print statement within an if statement. What we'll check is if apartment in quargs. If there's an apartment key in quargs, our dictionary, then print this line. Else we will print just the street. The person doesn't have an apartment, we won't print the apartment then. But if they do have an apartment, apartment equals number 100, then we will. 123 Fake Street, apartment number 100. Here's a challenge round. What if a user has a P.O. box? Let's change apartment to P.O. box. The string will be P.O. box number 1001, I suppose. I'll add an else if statement. Else if P.O. box in our dictionary quargs. Let's print the street. I'll copy this line, paste it, followed by a second print statement. Quargs.get P.O. box. There we are. Dr. SpongeBob SquarePants, 123 Fake Street, P.O. Box 1001, Detroit, Michigan 54321. All right, everybody, those are arbitrary arguments. When you invoke a function, you can pass in a varying amount of arguments. Set up your parameter to be args for a varying amount of non-keyword arguments, or quargs for a varying amount of keyword arguments. You can set up both in your parameters, which we did for this exercise. And well, everybody, those are arbitrary arguments in Python. Hey, everybody, so today I gotta talk about iterables in Python. An iterable, it's a category. Any object or collection that can return its elements one at a time is considered an iterable. If an object or a collection is considered an iterable, then it can be iterated over in a loop. For example, let's create a list of numbers. Numbers equals a list. I'll add the numbers 1 through 5 to keep it simple. Lists are considered iterable. We can use them within a for loop. In the context of a for loop, we're going to be given each element one at a time. Each element that we're working with, we can give a temporary nickname. Let's say number. For every number in my iterable of numbers, let's just print each number. This will give us 1 through 5. The name of the current element in our iterable should be descriptive of what we're iterating over. For example, I don't want to rename the current number that we're working with as something like blah blah blah. You know, this would work, but other people looking over your code might not understand what a blah 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 is, and I don't blame them. Each element that we're given from our iterable, the name should be descriptive of what we're given. Or you might see item. For every item in numbers, print each item. That's also a good choice. Now, you could even iterate backwards by enclosing our iterable within the reversed function. So take our iterable of numbers and reverse it. Then we get the numbers 5, 4, 3, 2, 1. If you would rather not print each element on a new line, we can replace the new line character at the end of print statements with something else. Print is a function. We can pass in a keyword argument of end. Rather than end each line with a new line character, let's end with a space. This will space out each of the elements. Or we could replace it with something else. Or what about a dash? After each element, append a dash character. We could even add multiple characters, such as a space, a dash, and a space if we so choose. It's up to you. Tuples are also iterable. Let's convert our list to a tuple by enclosing our numbers within a set of parentheses. And I no longer want this reversed. For every number in my iterable of numbers, print each number. Then again, we get the numbers 1 through 5. Let's cover sets. I will create a set of fruit, which I will name fruits. For a set, enclose any values within a set of curly braces. Let's add a string of apple, a string of orange, a string of banana, and a string of coconut. So with our for loop, let's say for every fruit in my iterable of fruits, I will print each fruit. That would give me apple, banana, orange, coconut. Now sets, they're actually not reversible, I will attempt to enclose our iterable of fruits within the reversed function. Here's what happens. We have a type error. Set object is not reversible. Sets, you can't reverse. Let's cover strings. I will create a string of name. Type in your full name. I'll use my YouTube channel name. For every character in my iterable of name, I would like to print each character. Maybe I would rather not have each character end with a new line. I will set the keyword argument of end to be a space. Last, we have dictionaries, which are the most complicated. Let's name this dictionary my dictionary. Dictionaries you enclose with a set of curly braces, kind of like a set. But each element is a key value pair. I will add a key of A with an associated value of 1, a key of B, which has a value of 2, a key of C, which has a value of 3. If you iterate over a dictionary, the dictionary is going to return all the keys, but not the values. We'll test that. For every key in my iterable of my dictionary, let's print each key. This would give me the keys of A, B, and C, but none of the values, 1, 2, or 3. If you need the values, we're going to follow this iterable of my dictionary, use the built-in values method. This will return all the values of your dictionary as an iterable. But let's rename key as value, because now we're working with the values. Then we're given all the values, 1, 2, and 3. If you need both the keys and the values, you're going to use the items method. We'll be given both a key and a value. Make sure that the value and the key is separated with a comma. Let's print each key, followed by the value. We get the key of A with its value of 1, B, 2, C, 3. We can reformat the output however we want. Let's use an f-string. I will add 2 placeholders. Let's print each key equals, then the value. A equals 1, B equals 2, C equals 3. Okay, everybody, so those are iterables. An object or a collection that can return its elements one at a time is considered an iterable, meaning that object or collection can be iterated over using a loop. And well, everybody, those are iterables in Python. Hello again. So today I got to talk about membership operators in Python. They are the operators in and not in. They're used to test whether a value or a variable is found within a sequence, which include, but are not limited to, strings, lists, tuples, sets, or dictionaries. Here's an example. I'm going to create a word, a secret word. Let's say apple. I'm going to turn this into a game. I will have a user guess a letter. I will accept some user input. Guess a letter in the secret word. What I would like to do is check to see if my letter is found in my word. I can write the following statement. If our letter in our word. In is going to return a Boolean value of true if that letter is found, or false if it's not. So if our letter is found, I'm going to print the following statement. I'll use an f-string. There is a, add a placeholder, insert our letter. Else, let's print, I'll use an f-string, our letter was not found. Let's test this. Guess a letter in the secret word. I will guess a capital A. So all these letters are uppercase. Do take note of that. Is there an A? There is an A. Let's guess a letter that's not within this word, such as Z. Z was not found. The in membership operator will test to see if a value or a variable is found within a sequence. If it is, it returns true. If not, it returns false. Or for the inverse, you could say not in. If letter is not in word, we would have to flip these statements around. If this value or variable is not found in this sequence, it returns true, otherwise false. So it does the opposite of in. Guess a letter in the secret word. Is there an E? There is an E. Is there a Q? Q was not found. Depending on the statement you're trying to write, you can use either in or not in, whichever makes more sense in that context. Let's go over another example. We were searching for a value or a variable found within a string. Let's try a set. Lists, tuples, and sets are going to behave similarly. I will create a set of students. For a set, you need a set of curly braces. Let's add a few student names, such as SpongeBob, Patrick, and Sandy. I will have a user type in a student to search for. We will accept some user input. Enter the name of a student. We're going to check if our student is in our sequence of students. If in returns true, let's print the following. I'll use an F string, insert our student is a student. Else, we will print, I'll use an F string, insert that student was not found. Enter the name of a student. Let's search for SpongeBob. SpongeBob is a student. Enter the name of a student. Let's attempt Squidward. Squidward was not found. And, much like the first example, we can do the opposite. See if a value or a variable is not in a sequence. We would have to switch these statements around. Enter the name of a student. Is Sandy a student? Sandy is a student. Enter the name of a student. Is Larry a student? Larry was not found. Now we'll cover dictionaries. I will create a dictionary of grades. Student grades, like a grade book. Let's say that the student of Sandy, she will be a key, has a value of A. Squidward, the key of Squidward has a value of B. SpongeBob, he is also a key. SpongeBob has a grade of C. Then Patrick. Patrick has a grade of D. Here is my dictionary of grades. Then we'll search for a student. Student equals input. Enter the name of a student. We'll check if, let me close this, if our student is found within grades, then I will print the following. We're looking for keys. Is there a matching key? If we find that student, I'll make this an F string. Let's display the associated value of that key. Students grade is, I'll add a placeholder. Once we find a student, we have to get that value at the given key. To do that, we'll take our dictionary of grades at index of student. This will retrieve the value at a given key. If we don't find a student, we'll output the following. Again, I'll use an F string. Student was not found. So now, if I search for a student, such as SpongeBob, we're given a grade. We're given the value at that key that we're searching for. Let's test Sandy. Sandy's grade is A. Squidward's grade is B. And Patrick. Patrick's grade is D. But Larry is not a student. If I search for him, well, Larry was not found. Let's go over one last example. We're going to create a variable of email. It's going to be a string. Type in whatever your email is. brocode@gmail.com. I would like to see if this email is valid. Does it contain @ and a period? I will write if our value of @ that character is in our email and a period is in email. We have two conditions. Check if @ is an email and check if a period is an email. If so, it's a valid email. Then we'll print valid email. Else we will print invalid email. Is my email valid? That email is valid. I'll get rid of the @ invalid email. I'll get rid of the period following Gmail. That email is also invalid. In this example, we're checking two conditions. If this value is found within this sequence, and this value is found within this sequence. All right, everybody, so those are membership operators, in and not in. They will return a Boolean based on whether a value or a variable is found within a sequence, which include, but are not limited to, strings, lists, tuples, sets, or dictionaries. And well, everybody, those are membership operators in Python. Hey, what's going on, everybody? So in today's video, I gotta explain list comprehensions in Python. A list comprehension is a concise way to create lists in Python. They're compact and easier to read than traditional loops. Basically, you have to follow this formula. For every value in something that's iterable, meaning you can loop through it, check some condition, then do this expression. So let me give you an example with using a traditional loop. Then you'll be able to see why a list comprehension is useful. We're going to create a list and double the numbers 1 through 10. Doubles equals an empty list. Using a traditional for loop, we will say for every value, let's say x, in range 1 through 11. Remember that in the range function, the second number is exclusive. This will give you the numbers 1 through 10. For the first iteration, x is going to be 1, then 2, 3, all the way up until 10. So we'll iterate 10 times. During each iteration, I'm going to take my list of doubles, use the built-in append method. We will append x during each iteration. That's going to be the value times 2. So if I were to print my list of doubles, here's the result. We have the numbers 1 through 10 all doubled. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is a lot to write. We can use a list comprehension to make this code more compact and easier to read. Here's how. We need a name for this list. Let's say doubles equals an empty list. Within our list, we'll follow this formula. We have an expression for value in iterable, and optionally, we can check a condition. We'll do this in exercises later on in this topic. We'll begin with for every value, let's say x. In our iterable is going to be a range 1 through 10. Again, for the first iteration, x will be 1, then the second iteration, x will be 2, all the way up until 10. During each iteration, what would we like to do with x, our value? Let's take x, multiply it by 2, and return it. Then, if I was to print my list of doubles, we have the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. For every value in this iterable, do this. Multiply it by 2. This is a list comprehension. It's a concise way to create lists in Python. We'll go over a few exercises. So this time, we will triple each number. We'll create a list of triples equals, let's say this time for every y in range 1 through 10, So we have to write 11, take y, and multiply it by 3. Then we will print our list of triples. 3, 6, 9, 12, 15, 18, so on and so forth. Let's square each number. We'll create a list of squares for every z in range 1 through 10. To square a number, we take that number, multiply it by itself. So the numbers 1 through 10 squared is 1, 4, 9, 16, 15, 36, 49, 64, 81, 100. So 10 times 10 is 100. Now we're going to work with strings. We'll create a list of fruits equals, think of some fruit. These are all going to be strings. Apple, orange, banana, coconut. I'm going to take each string in this list and make it uppercase. We could assign this to a new list, such as uppercase fruits, or we can simply just reassign it. Just to keep it simple, I'll reassign it. So again, we're following this formula. I like to begin with the for value in iterable portion. For every fruit in our iterable of fruits, what do we want to do? Well, let's take each fruit, use the built-in upper method to make it uppercase. Then I'm going to print my list of fruits. Each string in this list is now all uppercase. You could even cut down on one of the steps. With our iterable of fruits, I will place this list. And this does work too, although I do find this a little more difficult to read, but you can take either option. How about instead of making each string uppercase, we'll take the first letter of each string, then put it within a new list. So let's take each fruit at index of 0, that will give us the first letter. We'll place it within a new list of fruit chars, meaning characters. Here's the result. A, O, B, C. For every fruit in our list of fruits, return the first character of each string. A, O, B, C. Now we'll work with conditions. We'll create a list of numbers, both negative and positive. Numbers equals, let's say 1, -2, 3, -4, 5, -6. We'll create a list comprehension to create a new list where all of the numbers are positive. Our new list will be positive nums. Equals, we'll write a list comprehension for every, let's say, num in numbers. We'll write a condition. Return this number if our num is greater than or equal to 0. We do need an expression. If we're not modifying each value, we can just return the value of num. During this exercise, we're more focused on the if condition rather than the expression. If our value of num meets this condition, simply return it and place it within this new list. Let's print our list of positive numbers. And we have 1, 3, 5. Let's do this with negative numbers. I'll just copy what we have and change a few things around. This list will be negative numbers. Negative nums. For every num in numbers, check this condition. Check to see if num is less than 0. If so, return that number. Let's print our list of negative numbers. -2, -4, -6. Let's check to see if there's any even numbers. Even nums equals, for every num in numbers, check to see if our num is divisible by 2. And we can do that with the modulus operator, followed by 2. The modulus operator will give you the remainder of any division. If our number is even, number modulus 2 will equal 0. If it's even, this is going to equal 0. If it's odd, it's going to be 1. We're not modifying our value, we're just going to return our number. Our list of even numbers should be -2, -4, -6. Let me add one more value. Let's add +8. -2, -4, -6, +8. Maybe we'll add one more. -7. Okay, let's find any odd numbers. Let's copy this line of code. Replace even numbers with odd numbers. If num modulus 2 is equal to 1, that means that number doesn't divide by 2 evenly. Then we'll print our odd numbers. 1, 3, 5, -7. All these numbers are odd. Here's the last exercise. We'll create a list of grades. We'll create a new list of any grades that are considered passing, meaning they scored 60 or above. So let's say one student has a grade of 85, another with the 42, 79, 90, 56, 61, let's say 30. I will create a new list of passing grades equals, again, follow this formula. For every grade in grades, check our condition. If our grade is greater than or equal to 60, we will return the current grade. Then let's print our list of passing grades. That will give us 85, 79, 90, and 61. All of these grades are greater than or equal to 60. All right, everybody, so that is a list comprehension. It's a concise way to create lists in Python. They're compact and easier to read than traditional loops. Remember, for every value in your iterable, optionally, you can check a condition. You can write an expression to modify that value if you choose, and return something. All right, everybody, so those are list comprehensions in Python. Hey, everybody. So today I'm going to explain match case statements in Python. If you're familiar with other programming languages, this is also known as a switch. Match case statements are alternatives to using many else-if statements. We execute some code if a value matches a case. The benefits of using a match case statement is that they're cleaner and the syntax is more readable. In this sample program, I have a function. There is one parameter, a day. Day will be a number, ideally a number 1 through 7. Depending on this number, we'll return a string corresponding to the day of the week. If day equals 1, then it is Sunday. 2, it is Monday, all the way up to 7, where it will be Saturday. I do have an else clause if we pass in something that's not valid, like pizza. Pizza is not a day, but it really should be. Not a valid day. A cleaner and more readable alternative is to use a match case statement instead of many else-if statements. Here's how. I'm going to take my if and many else-if statements and enclose them within a match case. Match case. The case is going to be the value we're examining. The case will be day. Colon. We're going to examine our value of day against matching cases. We're going to replace if day equals with the following, just simply case. So let's do that with each of these statements. If you have an else clause, you're instead going to have a case of underscore. An underscore in a match case statement is a wildcard. We will perform this case if there are no matching cases. This case would function as the else statement. Here's what we're working with now. If I pass in 1 and return the day of the week, we would get Sunday. 2 would be Monday. 3, Tuesday. 7 is Saturday, and then let's try that day of pizza. That is not a valid day. A match case statement is an alternative to using many else-if statements. I find this much easier to read than the many else-if statements. Both would technically function. Let's go over a second example. We will create a function of isWeekend. We have to pass in a day. This time our day is going to be a string, such as Monday. The value for each case, instead of a number, is going to be a string. If our day matches a case of Sunday, let's return, how about a Boolean of true? We're checking to see if it's the weekend. If our day is equal to a case of Monday, then we will return false. Let's do this with the other days. I'm going to fast forward the video